Hello advanced grad math students, welcome back to another unit. This is Unit 2 in Unit 2 notes, combining like terms and simplifying expressions. As you noticed from one of the videos and your pre-benchmark, we are putting things together, but not everything fits together evenly. So let's look at the essential question. I can use the order of operations correctly to simplify and evaluate numeric expressions. That's similar to last unit, and I understand the concept of positive and negative numbers and can use rational numbers in complex ways to solve real-world math problems. This includes combining like terms. Let's get to our notes. So we have some vocabulary here. The first vocabulary word is variable. A blank or a symbol that represents a blank. A variable is a letter or symbol that represents a number. So down here where we see 4x, that x represents a number. It may represent 5, it may represent 7. Sometimes there's only one thing it can represent. Other times it's something that we don't know and it may change. So as a variable, we may put different quantities into it from time to time. The next vocabulary word is term. Term, a number or blank separated by a plus or a minus sign. A term is a number or a letter that's separated by a plus or a minus sign. So this expression has two terms. There's this term, the minus sign separates it from the next term. Down here there's 1, 2, 3, 4 terms when this is first written out. The next vocabulary word or phrase, combined like terms, and that's our Unit 2 title. Putting terms that are alike together and then simplifying them. Expression is our last vocabulary word. An expression is a math sentence made up of operations such as plus and multiply, subtraction, and divide or division, and symbols. So this whole thing would be called an expression. This expression has two terms. This whole expression here has 1, 2, 3, 4 terms. Let's move on. So this next part we are going to look for things that are alike or on the same team. You can combine terms only if the variables are exactly the same. In this math expression, we have variables of a and numbers without variables. We can combine the a's, so one of the strategies Ms. Hoffman and I use is either circling or starring or using highlighters to help separate what's on the same team. So we have 3a and a plus 10a. Notice that I'm circling the plus because that actually belongs to the 10. Then on the other team, I'll use triangles for this. I have a plus 8, 6. So when we combine 13a with a positive 6, there'll be a plus there. If this was a negative 6, then there would be a minus there. In the next part, it says you can only combine terms when the variables have the same exponent. Remember from PEMDAS, an exponent is that number that sits really high above a number or a letter. Here, this has an exponent of 1, so we don't show it, and this has an exponent of 1. So we will box those in purple, remembering that that plus symbol in front of the 8b goes with it. And in red, we're going to do the b's that have an exponent of 2. We'll do that with like a squiggly little blob, and we'll get the plus here with the 11b squared as well. And now we need to combine the purples and the reds. Part of the reason I also included the plus with the 4 and the plus with the 11 is that I want to keep them together as I shift them over. This plus with the 8 is going to move over here with when it combines with 3b. So now I've just realigned it, and I've moved the terms that are alike together. 3b plus 8b plus 4b squared plus 11b. Now I can combine the purples, and I can combine the reds. When I combine the purples, I get 11b. When I combine the red, which are b squareds, I get 15b squared. They both have b, but this has an exponent of 1, and this b has an exponent of 2. They cannot go together. Exponents are extremely powerful, and we can't just assume that it doesn't have any effect on the b. It's like a superpower. On the next part, we have some problems. We are going to highlight what's similar and then combine them over here. You already see that I've done that for you with highlighters. There are no variables here. Nothing's to an exponent, so I can just combine 3 plus 5 plus 1 plus 2. When I rewrite it, it looks the same as it originally did. When I add them all up, I get 11. You've done that thousands of times before. In this next one, I'm going to highlight the B's differently than the A's, or I could have used circles or squigglies or triangles, whatever works for you. You could use 2 different color markers if you're using your marker board. The next step is to put the B's together, 3B and 8B, and then the A's together, 7A and 8A. Remember, that plus goes with the 7. If that was a minus, it would still go with the 7. And when the 8 moves over, it's got a plus hanging there. When I combine them, I'm going to have my B part of the expression and my A part of the expression. In the next part, I have 1, 2, 3 terms. 2 terms are alike. They have D's. 1 term is different. It has no variable. So I'm going to end up with 2 terms in the end, 1 with the D's and 1 without. When I combine them, I see that I end up with the 2 terms, like I had said, 10D minus 8D. This has 1, 2, 3, 4 terms. But 2 of them have x's, and 2 of them don't, but they're similar. So again, my answer, I'm going to have 2 terms. But first, let's put what's alike together. We have 3x and plus 8x. Oh good, you notice that I forgot to highlight some of that plus sign there. We want to make sure that shifts over. And then I have a plus 7, and can you tell what that is? A plus 3. So when I put those together, I end up with 3x and 8x, and I have a 7 and a 3. And there I'm left with 11x plus 10. On the next part, I'm left with k's and 5 and a 3. So we're going to put all our yellow k's together, including moving the addition symbols. And all 3 of them are sitting there. And my 5 and my 3 are sitting there. We have 1, 2, 3, 4, 5 terms, but 3 of them are black, which will become 1 term, and 2 of them are blue, which will become another term. So my answer is going to have 2 terms, and I'm left with 9k plus 8k.
All right, everybody, who's sick of listening to Mr. Benson? It's time to take a break, get up, go to the bathroom, get a drink of water, grab a snack, do 5 jumping jacks, and come back ready to learn some math.
Second side, what we want to make sure we move the addition and subtraction symbol, the operation symbol, with the term that's in front of it. So like I was saying before, if we move the 2g, we need to move the minus with the 2. It does not belong to the 5. It does not belong in a frozen position there. It is owned by the 2, just as this addition symbol here is owned by the 9 in front of it. The next note that we need to remember is this is extremely, extremely important with subtraction. So let's see how that plays out here. We have a 7g and a minus 2g. So like I said, the minus 2 will shift over. And we have a positive 5t and a positive 9t. So those will become addition problems. So we have 7 minus 2 which is 5. G goes along with it. And 5 plus 5 is? Positive. Yep, positive. Now here, again, I've labeled, and Miss Hoffman's labeled, and you should label too. We've labeled the y's. I have a 10y and a minus 8y. Yes, there's a y there, but remember from the other side, there's an exponent of 2. Y to the 2 is the same thing as y to the 2. It's not like y. It's got a superpower. When we move the 10 and the 8 together, the negative comes along for a ride. When we move the negative 4y squared with the 11y squared back here, they go together. We combine them, and 10 minus 8 is 2y. And negative 4 plus 11 is, it's a positive number, right? Because 11 is bigger than 4. But it gets smaller. It's a 7y squared. Nice job. Let's move on. When we're distributing, that's a fancy term for multiplying or sharing. If I were to bring cookies to class and I distributed 3 to everyone, I would give everyone 3. When we distribute, that means we share. When we share, we multiply. When a number is written next to a letter, like 10y, it really means 10 times y. This means 2 times y. When it's written next to a parenthesis, it also means to multiply. We talked about that a little bit with order of operations. We're going to use that a lot moving forward. So if we look down here at our example, it says 2D. What it says in words is TWO times D, or 3x means 3 times x. When we multiply across parentheses, we must remember to multiply the outside number by each individual part. Let me say that again. When we have a 5 on the outside, we must share it with the 8x and the 2. If I brought my pairs to class, was to share my pairs from my pear tree, and I did not share them with you, and you really liked pears, you would be upset. So we need to make sure we share the number outside the parenthesis that's touching it with the other classmates that are inside the parenthesis. Miss Hoffman likes to talk about this in terms of rainbows or football, Hail Mary passes, or maybe dolphin tails. So in order to keep track of what we're doing, we're going to do it one step at a time with a Hail Mary pass or a rainbow. 5 times 8, we write like this, 5.8x, 5 times 8. Then we do the next Hail Mary. We share 5. So I want to go blue. We share 5 with the 2, and that's the same thing as 5 times 2. Now where did this plus come from? It just comes on over. 5 times 8 is 40x. 5 times 2 is 10. We can't put x's with non-x's, so we just end up with 40x plus 10. Let's look at the next one. The rainbows. Some people have a tendency to do the rainbows right away. What we want you to do is do one rainbow and then write the multiplication problem over there. My first rainbow, when I wrote 3 times 2y, I did my second rainbow, 3 times 7, and I get 6y plus 21. Next one, we're going to make a little harder. If you don't have anything here, I want you to add a plus 2. First step, I'm going to take the negative 4 and multiply it by the 3d. Write it negative 4 times 3d. Then I do my dolphin jump, and I go with green, 4 times 10. And then this 2 goes with those, so I write it right next to it. When I add them together, I get negative 12d and negative 40 plus 2, which ends up with negative 12d minus 38. Have a good day.